Hello, and welcome to Amazon Web Services webcast, Introduction to Amazon Machine Learning. My name is Alex Ingerman. I am a product manager in the machine learning platform team with Amazon Web Services. Today's presentation is to introduce you to Amazon Machine Learning, the new machine learning platform from Amazon. There are a few things I would like to cover in this presentation. I'll start off by talking about machine learning and its place in the overall data ecosystem. I'll talk about smart applications which are enabled by machine learning technology. I'll give a few examples of smart applications, and I'll also give a counterexample of how to not build or use smart applications. Then I'll jump into the Amazon machine learning product features and benefits. I will spend much of the second half of the presentation showing you a step-by-step walkthrough of building a machine learning model, deploying it and using it to obtain predictions with Amazon Machine Learning. And finally, I'll open up the floor for a Q&A. So I want to start by talking about the three types of data-driven development. Our customers have told us that there are really three categories of uses of data that's collected as part of their businesses. First is the retrospective analysis and reporting, where data is collected, stored, and then analyzed to answer specific questions about what happened in the past. For example, many of our customers use Amazon S3 to store large volumes of structured data, and then they process this data with EMR using tools like Hive and Pig. Others may store data in Amazon Redshift, our petabyte-scale data warehouse, or in traditional database systems that are managed by Amazon RDS. There are many mechanisms, but no matter what the mechanism, this approach is valuable for understanding how customers use your applications or how data flows through them, and then using this information to improve your businesses. For example, you can gather information about how long customers spend in each part of your application or website, and how often they're able to successfully complete their task, and then use this information to find trouble spots and to improve the application or the website. The second kind of processing that we see commonly is to capture information right as it comes in, and then use it immediately to take action. Using products like Amazon Kinesis or EC2 and Lambda, customers are able to immediately extract value from incoming data streams, for example, by dashboarding the real-time state of their applications, or by building applications that immediately respond to events as they happen. And this is really powerful. It is an incredibly powerful way to use data to be able to see what is happening to your business in real time and to react to it. But there is one more step. There is one more step beyond the looking at retrospective analytics and beyond looking at here and now. We can use the data we already have to make accurate and actionable predictions about what will happen in the future. And then we can build a new breed of smart applications using these predictions. It's really exciting. So let's talk about machine learning and what that is. Machine learning is a broad umbrella term for the technology that finds patterns in existing data and then uses these patterns to make predictions on new data points. And there is a really simple equation here. Take your data, add machine learning technology, and what you get is smart applications that can really make a difference for your business. So let's look at a few examples of smart applications. A very common example that you have probably encountered is recommendations or personalization, or in very general term, based on what you know about the user, can we predict will they use the product, how will they use it, and then act on this prediction. Based on what you know about an order, we can predict, is this order fraudulent? Should we flag it for additional review? Should we cancel the order? Should we confirm it with the customer? Based on what you know about a news article, what other articles are interesting? What other content can be shown? These are three examples, but there are so many more examples. I'll just run through this list very quickly, and I'll come back to some of these later in the presentation. Fraud detection of all kinds is a great use of machine learning technology because we can learn from fraudulent transactions in the past, and we know a transaction is fraudulent, for example, because a bank has eventually declined it. We can use this information to detect fraudulent transactions and not allow them to go through. Personalization of all kind, I have mentioned already. Targeted marketing, such that matching up customers and offers, or choosing the right target marketing campaigns to run. Content classification of all kinds is a fantastic use of machine learning. Anytime you have content, and especially when it's unstructured, free text content, and you would like to put this content into categories and then apply business rules to categories, things like taking documents and assigning labels to them, or matching up documents and people, as in this example, hiring managers and resumes, a great example of machine learning technology being able to make a real difference. Churn prediction within applications, knowing how customers use your application, how satisfied they are, how likely they are to abandon, very important for many businesses. And customer support is an up-and-coming and very powerful use of machine learning technology, being able to listen to your customers through all channels as they give you feedback or ask questions and route these to the right people. So I want to talk a little bit about the counter pattern of building smart applications. I want to set up the stage a little bit. So here what we have is an example of a targeted ad. It says, "Dear Alex, this awesome quadcopter is on sale for just $49.99. And this is a great ad because I'm very interested in quadcopters, and this is a great price for it. I'm very interested." So let's consider how this ad came to be. Well, we might imagine that a marketing manager or retail merchandising manager had a quantity of quadcopters to market, and they came to a developer and asked, "Can you give us a list of people to whom we should send this promotion?" So how might a person go about it? Well, we can write a SQL query, a very simple one, to just find customers. This query gets all the customers that have placed an order in the last 30 days. This query is very simple, it's very easy to understand, it's just not a very good query, because just because I placed an order in the last 30 days, it does not mean that I'm interested in quadcopters. So we can make this query a little more complex. We can say, let's only target customers who have purchased a toy in the last 30 days. It's a little better, but there are all kinds of toys out there. It's still not a very good query. We can make this even better. We can make this query much more complex. We can say, well, let's look at what customers have actually purchased, and let's only send this email to customers who have purchased a toy that has the word helicopter in description, and they've done it in the last 60 days, or they've placed at least a couple of orders in the last 30 days that were all for a large amount of money. So you can see this query is getting large. There are numbers that appear in it, some kind of magic numbers. But this query is still not very good. It doesn't seem very prescriptive. For example, what about people who have purchased some things that were quadcopters and not helicopters? Okay, we can make this query, we can relax the query description. Now it's anything with the word copter. It's a little better, but maybe we should go back further in time. Maybe we should look at the last 120 days of data. And maybe we should tweak the query some more and look at how long it's been since expensive orders were placed. And maybe we can tweak it again and again and again. And this will never work. The reality is that there are patterns in the data. There are rules you can mine from it, but just blindly guessing and writing more and more complex SQL queries and that have more and more of these magic numbers is not an approach that is going to work. The right approach is to use right technology, and this predictive technology here, to learn business rules from the data you have, so that they're not magic numbers, they're based in evidence and fact. And that's what a smart application recipe is. Taking the data you have, applying the right predictive technology to it, finding these rules, and then acting on the outputs. So you might ask, why aren't there more smart applications? And what we have seen is there are really three reasons. One is machine learning expertise is rare. The second is that building and scaling machine learning technology is hard. And finally, the third is that closing the gap between models and applications is time-consuming and expensive. And I want to dive into this. So let's talk about expertise really quick. There is, at the end of the day, a very limited supply of folks whose titles may be data scientists, machine learning scientists, data analyst, research scientists. The title doesn't matter. What matters is that companies of all size, in all industries, are feeling the talent shortage. There are not enough of these folks to go around. And outsourcing machine learning model and smart application development is an option, but it's a very expensive option. When we talk about technology, it takes what we know, our customers have told us, and what we have seen inside Amazon, is that it takes significant time and engineering expertise to build machine learning software that scales to your business. There are many tools out there, but these tools are often oriented in machine learning experts, and they're not built for demands of large data sets with data types often encountered in real world. It's not uncommon to see machine learning software out there that can only work on a narrow selection of data types. It can only work on numeric variables, and if your data is not numeric, too bad. A bigger problem, there is some good tooling out there, but a bigger problem is this incredible fragmentation. To build an end-to-end machine learning application requires not just the learning technology. You also need the data connector technology. You need the data transformers to get the data to learning algorithms. You need deployment technology to make models available. You need evaluation technology to compute metrics. You need data pipelines to move data around, and so on and so forth. What our customers tell us is that no matter which technology they start with, they end up doing a lot of the engineering work themselves just to connect all the pieces and make them play nice. And then the third barrier is being able to tie machine learning into business applications, to go from having a model to having an application that is actually using that model. And this is a lesson that many early adopters of machine learning technology learned the hard way. A lot of the machine learning software out there is focused on making ML models and not on using these models to make predictions. And for much of the software, generating predictions is an afterthought, and the code that generates predictions can only run on a single machine. It may not be robust. It may be limited in how many predictions it can generate. And most of the time, it cannot generate these predictions at anything resembling real time. And in addition to just getting the predictions, there is all this work that needs to be done on things like data pipeline automation, model lifecycle management, updating and retiring models as they're deployed, and so on. This is a lot of work. And to add insult to injury, it's a lot of work that gets repeated every single time you build machine learning application, because each one ends up being a little different, and you need to do a slightly custom solution every time. The end result is, to do machine learning today, you need a team of engineers, you need a team of data scientists who are working together. And much of what they build can end up being custom codes that will not be reused. And this is slow, it's expensive, it's risky. And that is why the number of machine learning applications out there is far smaller than what it could be. So we ask, what if there were a better way? Well, today I'm here to tell you about Amazon Machine Learning. It's the newest addition to the Amazon Web Services family. Amazon Machine Learning is easy to use, and it's intended for developers, people who are already most connected and familiar with data instrumentation, pipeline, and storage. It is based on the same robust ML technology that is already used within Amazon's internal systems and responsible for generating billions of predictions on a weekly basis. Amazon Machine Learning is built to make it simple and reliable to use the data that you're already storing in the AWS cloud in products like Amazon S3, Redshift, or RDS. And lastly, Amazon Machine Learning is built to eliminate the gap between having models and using these models to build smart applications. Production deployment is only a click away, and what I'll show you later is, for some kinds of applications, there is not even a click. The model is ready to be used immediately after being built. I want to start by talking about the ease of use, because it was so incredibly important to us as we built this product. We wanted to make the product available to all AWS developers. And what we know from both our internal experience and speaking with our customers is that using machine learning to build in real world falls into two types. The first stage is experimentation. You try out different data, different ways to transform that data, different ways to use machine learning technology to approach a problem, and so on. And in this stage, it is very helpful to work with interactive tools that let you do many experiments easily. The second stage is productizing the models, and this involves automating model training, deployment, and use. So for example, tying the prediction generation activities with your application's business logic. And there is just no substitute for having a capable API to achieve this. And that enables the machine learning piece to act just as robustly as the rest of your application. Most machine learning toolkits out there do one or the other. They're either intended for interactive data analysis and model building, or for programmatic model building and querying. We knew that to enable AWS developers to easily use machine learning, we needed to support both types. And so what you'll see in Amazon Machine Learning is a powerful service console that enables you to connect to your data source, to train new models, to measure their quality, and to manage these models easily without writing any code. And that enables you to spend more time thinking about your data and your business problems, and less time just dealing with all the technology pieces, tinkering to connect them together. Once you do have models that are ready to be productized, you at that point have a fully capable API available to deploy these models and to query them for predictions. It's a complete life cycle. We have included Amazon Machine Learning API support into all the major AWS SDKs, and we took specifically the prediction querying capabilities and bundled it into the AWS mobile SDKs, so it's now very easy to write an iOS or Android application that can request predictions and use it immediately. So let's talk about the technology a little bit. Amazon Machine Learning, as I've mentioned already, is based on the same technology that has long been deployed within Amazon, is used to generate tens of billions of predictions weekly. And when I say technology, I mean not just the learning algorithm, which is important, but it's not the only part of machine learning systems. Amazon Machine Learning also comes with technologies that suggests data transformations based on your data that will improve models' quality. It includes functionality for alerts when known pitfalls are encountered in your input data. For example, when some attributes have many missing values, or when the model was evaluated with data that is significantly different than the data that was used to train it. And that is one example of something that is an industry best practice that we have built right into the product, among others, all around the goal of making the models you create powerful and for making the field of machine learning more accessible to machine learning, to AWS developers. And finally, a word about speed and scale. Amazon Machine Learning can create new models on up to 100 gigabytes of data. Today, you can use these models once they're created to generate billions and billions of predictions. And you can obtain these predictions in either batches or in real time. And I'll get to the prediction interfaces soon, and I'll show you what those look like. It's important also to mention Amazon Machine Learning integration with the AWS Data Ecosystem, because getting data is often the most time-consuming and the most difficult step of getting to the machine learning. Amazon Machine Learning can access data that is stored in CSV files in S3 or in tables in Amazon Redshift or in MySQL databases that are managed by Amazon RDS. And what that means is, especially for Redshift and RDS, SQL queries can be written easily to grab exactly the right data and provide it to Amazon Machine Learning to train the models and to obtain predictions. Predictions from Amazon Machine Learning are then output to S3, and what that means is that S3 is a universal interface. No matter how your application is written, if it can read an S3 file, you can read predictions and use them in your application. And of course, there is a security layer built on top of all of this. Security is incredibly important to us at AWS. So you can use identity and access management for fine-grained permission policies for who is allowed to build models, who can query the models for predictions, and so on and so forth. I want to talk a little bit about the model and prediction services. We set out with Amazon Machine Learning to build a prediction service that is fully managed. And what that means is there are no servers to provision. There is no capacity reservation that you need to worry about. As soon as a model is built, it is ready to be used to generate predictions. For real-time prediction generation, there is a one-click production model deployment. For batch prediction generation, and again, I'll come back to the generation methods in a second, the click is not required. The models are immediately ready to be used. Any model can be programmatically queried for its metadata, which enables you to very easily write code that creates a new model that is using the same settings and the same data transformations as an existing model, because all models are self-describing. And model usage can be monitored with CloudWatch metrics. All of these things add up together to a service that is fully managed. It gets out of the way, so you can just think about your smart applications and not the infrastructure and the nuts and bolts of getting your application running and managing and monitoring it. And finally, I want to talk about costs. Costs are a big barrier to entry for many machine learning applications out there, or machine learning technologies out there. We set out to make the cost easy to understand, simple, and low, so it's inexpensive. There are really only three parameters. All aspects of data analysis, model training, and evaluation, basically anything you would do to create a machine learning model, are charged in units of instance hours, a simple 42 cents per instance hour. Predictions are charged at the rate of 10 cents per 1,000, and the rate is the same for batch and real-time predictions. For real-time predictions, there is also a small additional charge to hold the capacity available to make sure that your application will have dedicated resources to generate these real-time predictions. This capacity charge is typically very small compared to the real-time prediction charge. So these are the only three numbers you need to know to estimate how much your machine learning application will cost you to develop and to obtain predictions from. And I want to talk about what kinds of models you can build with Amazon Machine Learning. What can you do with it? There are three supported types of predictions built into the system right now. The first is binary classification, and it is used to anytime you need to predict an answer to a yes or no question. And an incredible number of machine learning applications out there are actually binary classification applications. That is one of the most flexible and commonly used types of machine learning in the business. So an example of binary classification problem is this order fraudulent? Yes or no? Will this customer convert, for example, from free to paid tier? Yes or no? Which article should I show next? That doesn't seem like a yes or no answer. But what you have to keep in mind is along with a yes or no answer, you also get a confidence score. And that enables you to make a query that, or to make a model that asks the question, will this user click on this article? Will this user read this article? Will this user be satisfied with this article? Which is in fact a yes or no question. You can generate multiple predictions for several different articles you have available, sort them by the prediction score, and takes the one with the highest score, or the top 3, or the top 5. And that enables you to create a very easy and powerful experience for showing custom or personalized content to a customer. The second type of machine learning is that's supported by Amazon Machine Learning is multi-class classification. And that is used when there is a list of correct categories and a new item comes in and it needs to be assigned a category. For example, what is the genre of this movie? We know all the different genres that are out there. A new movie comes in and we want to assign the genre based on the movie metadata. Or looking at something like customer service. When a customer contact comes in through an email, through chat, through a form on your website, what is the root cause of this customer contact? Can we predict it based on the contact text and other metadata? That is a great example of a multi-class classification problem. Finally, the third type of supported type of prediction in Amazon Machine Learning is regression. And regression is used to predict the value of a numeric variable directly. So how many units of this item will we sell next week? If we can make this prediction, we can of course affect how many will buy and where they're warehoused. Or how long will this user session last? Knowing how long the session will last allows us to do things like target offers to this user. Cross-sell or an upsell offer is a classic example. There are other examples too. If you're in real estate business, knowing how much will this house sell for based on the house metadata is very powerful. So what I want to do now is I want to take you through a little journey of what it's like to build a smart application with Amazon Machine Learning. And this journey really has 3 stages. In the first stage, we train a machine learning model from the data that is already available. That's our historic data. In the second stage, we evaluate the model to see how good it is and we optimize it. And in the third stage, we get predictions. So let's start with the model training step. And there are a few steps within that. We start off in Amazon Machine Learning by creating a data source object pointing to your data. A data source is an object within the system that contains all the metadata, and where the data is found, and what its format is, and so on. It also contains summary statistics on the data that enables you to explore it and to find data problems, and I'll show you what that looks like in just a second. Once you go through the exploration and data understanding step, then the final step, the final stage is to actually transform the input data and to train your model. And what I'll show you is a few screens of involved in each one of these stages, and at the end I'll show you a code snippet that accomplishes the same thing as the screens. The choice is yours. As I've mentioned earlier, what we find is most customers prefer to use the interactive tools for the exploration stage and finding the right model. And then once there is a model of the right quality that is ready, they go to the API to productize it. So to start off, I'm going to walk you through a few screens. We start off in Amazon Machine Learning Service Console with a wizard. The first stage is to input the location of the input data. You can see in the screens that we can put in a S3 location, or we can click on the Redshift radio button, which allows us to enter the name of the Redshift cluster and the SQL query we'd like to run. Once we specify the data, the next step is to specify the schema to let Amazon Machine Learning know the names and types of different fields. To lessen this burden, Amazon Machine Learning has schema guessing built right in. So when data is provided, Amazon Machine Learning will look at the data as it comes in and infer the schema for each column or each variable in the input data. But there is this review step for you to take a look and make any adjustments as needed. The third stage is to specify the data target. Target is what we're trying to predict. This is an attribute that's only present in training data, but is not present at the time of prediction. So to give an example, if we have a machine learning model that predicts whether an order is fraudulent or not, the target attribute would be a binary variable and would be 1 if the order is fraudulent and 0 if it's not. For historical data, we know which orders are fraudulent because these are the orders that have been declined by the bank. We have this information. Of course, when a new order comes in at prediction time, we don't have this information. That's what we're trying to predict. And so the target attribute is this thing in our training data that is only present in training data that we will predict when we get to the prediction stage. And finally, we get to the review step, and our data source is off, and it's being created in the background by the service. And I want to show you a quick code snippet. I'm using Python SDK here just for conciseness, but as I've mentioned earlier, we have a full support for Python, Java, PHP, JavaScript, Ruby, the full suite of AWS SDKs. You can work in whatever environment is best for your business. So what I'm doing here is I'm calling an API called create data source from S3 because I'm starting with an S3 data. I create a data source ID, which is the IDs that I'll use to refer to this data source later on. And I provide my location in the S3, and I provide a location of a file containing my schema. If I'm working through the API, of course, there is no UI for me to verify the schema visually, so instead I can provide the schema as a text file on input. This works great if I've already know the schema because I've worked through this with this data previously through the UI. Now I can just provide it and move on. So the next step is to explore and understand your data. And this is absolutely critical. Every data set, every single one, is broken in some way. There are missing values, there is data that has been improperly instrumented, there's data that's gotten corrupted in one way or another. When you speak with a data scientist, they'll likely tell you they've never seen a perfect data set. And it's really important to explore the data and understand where it's broken and what are the mechanisms of this breakage. One thing I want to make sure I mention is that Amazon Machine Learning does not expect your data to be absolutely perfect. Horrible things will not happen if some of the records are malformed or if some of the attributes are missing or invalid. But it is important for you to know just how often this happens and in what attributes. And so we've built some data exploration tools that help you see that. So I'll show you our data insights or data report screen. We start off by looking at target visualization. So in this case, we have a binary classification problem like fraudulent order screening problem I've mentioned earlier. And so right away, by looking at the simple visualization, we can see there are not that many fraudulent orders. Most orders are not fraudulent. That's great. That matches what our expectations are. But we can go further. We can look at all the different variables in my input data. And for each one, Amazon Machine Learning will pull out some key information. So here we're looking at categorical variables. For each one, you can see how many unique values are in this categorical variable. And this is important. If you have a variable named day of week, and you see that it has 8 unique values, you know that something's wrong because there are only 7 days in a week. Probably there is an attribute in there called NA or question mark or empty. This alerts you to a data problem you have, and you can estimate how big of a problem it is by clicking on this little preview of a histogram on the right side. And you get the full view for this categorical variable of all the different categories in it and their counts. And there is a special category on the right. It's in blue for all others. So what we see here is the top 10 or so categories, top 10 or so values of this categorical variable, and then all others. And we can see all others is not a big category. Most of the weight of this variable is concentrated in the top 10. And this may be the right thing. There is no such thing as right histogram or wrong histogram. All of this is built around the idea of enabling you to look at the data and making sure that it conforms to your expectations. And if it doesn't, one of two things is happening. Either the data is incorrect or your expectations may not be accurate. It's important to be able to dig in and understand. And I'll show you, of course, we do this for different kinds of variables. You can click on any category and see some sample records for each of that category, so that if something seems not right, you can look at what entire records look like and see if you can infer something about the mechanism of why this does not seem correct. There are included in the data insights are reports for categorical variables, which we just look at now. For numeric variables, which I'm looking at now, here we have a histogram of numeric variable, and we can adjust the bins and so on. And other supported types in Amazon Machine Learning are free text and binary. So now we're done with data insights. We have looked at the data. It's time to train the model. So let's start by walking through a wizard. We start off by specifying the ID of the data source that contains the data you would like to use to create your model. As you might recall, we created data source earlier. We have an ID for it, and now we just provide this ID, and instantly Amazon Machine Learning knows where to find the data, how to access it, what the distributions of different variables are. All of this is used as a part of the training process. So here we have typed in an ID and selected it, and we see that the status of this data source is completed. We can go ahead and use it. The next step is to select the path, and there are two paths. There is the default path where Amazon Machine Learning applies the industry best practices. These are things like splitting up the input data automatically into a training evaluation set so we can measure the model quality automatically. These are things like taking the input data and transforming it in a way that's most conducive to machine learning. I'll show you what that looks like in a second, and so on. And then there is a custom path, which allows custom control of data transformations and model parameters. So let's stick with the default path here. Immediately we go to the review step. We can see some information on input data. We can see some information on model settings. And these have been, as I just mentioned, these have been automatically selected based on your data. There is something at the bottom called a recipe. A recipe is our term for a little built-in language for transforming the input data to make it most conducive to machine learning. I'll give an example of transformation. If you have text data that comes in, for example, you have emails and you want to detect if an email is spam or not. If you just take the entire email and represent it as a single string and ask, is this email junk? That's a very difficult question to answer because it's just a sequence of bytes, and every sequence of bytes is different. It's hard to learn a pattern. But if you take that string and you break it up into individual words or groups of words, then you can start learning association that some words are very indicative of spam models and some are not. So a recipe is our language for specifying data transformations that are built right into the system. All you have to do is say, apply this transformation to this variable, and Amazon Machine Learning takes care of the rest. You can find documentation for all the supported data transformers on our documentation site. So I'll show you quickly what a recipe looks like. I clicked on that recipe show link. Here we have a list of variables and transformations applied to each. I'm not going to go into full details, but at the end of the day, these are just names of variables followed by the transformations to be applied to them, and there are some convenience functions, and they're like grouping many variables together and applying a function to all of them. And finally, I'll show you again a quick code snippet. We call an API called create_ml model. We pass in an ID of the model, we pass in the type of the model, in this case it's regression model, and we pass in the ID of the data source. And that's all it takes. There are optional parameters to pass in model settings and recipe and so on, but at the minimum, these three parameters result in a machine learning model being built. All right, so we have a model, great. Is it a good model? The next step is evaluating and optimizing the models that we have just built. And to explore the model, we have built experiences into Amazon Machine Learning that are highly interactive, and they're tailored to different kinds of models that you can build. So I'm going to show you a couple of pieces of UI here, and then I'll deep dive into one of them. The first one is a visualization and exploration experience for binary classification model, where we see the kinds of mistakes that the model makes on an independent training set, which, as you might recall, just a couple slides earlier, I showed you how Amazon Machine Learning can automatically reserve that evaluation set. We'll look at that in just a little more detail in a second. The second experience I'll show you is for numeric regression models, where we show the distribution of the errors the model makes. This is important for you to understand how accurate is this model and when it does make a mistake, what do these mistakes look like? How are they distributed? The third experience is for our multi-class classification models. You can see the misclassifications. You can see how different classes are guessed correct, whether they're guessed correctly or incorrectly. Ideally, you want the diagonal line to be dark blue and everything else to have no color, which means that the model is perfectly correct. But when the model does make mistakes, you can see what these mistakes look like. You can see that some classes are commonly confused, and you can learn something from this and go back and improve your model. And finally, I want to make sure I mention that Amazon Machine Learning computes summary metrics for each models that are built. And these are industry standard metrics that are different and appropriate for different model types. For each one, Amazon Machine Learning will also compute a baseline and let you know how you're doing compared to a simple baseline. So let's look at really quick at what it's like to fine-tune model interpretation. And this is an incredibly important step. Here we have a model. Imagine this is a binary classification model that predicts whether an email is spam or not. If you think about it for a second, this model can make two kinds of mistakes. It can make a false positive mistake, where it takes a legitimate email and says, oh, this email is spam, and then it gets routed into the spam folder. And it can make a false negative mistake, where a spam email comes in and the model thinks it's legitimate and it goes into your inbox. One of these is much worse than the other. If I get a spammy email in my inbox, the cost to me is a little bit of time and annoyance. If I get a legitimate email going to my spam folder where I never go and look, I may miss out on something very important. So what we can do is we can take the model which is built, and we can adjust its interpretation by moving the score threshold to say what we want from this model is we want to reduce the number of false positives. We'll even accept slightly larger number of false negatives, but it's incredibly important to have a small number of false positives. So in this example, I'm going to grab on the slider and I'm going to move it to the right. And as I do so, you will see that the number of false negatives and false positives at the bottom on the left-hand side changes as well. So this is an incredibly important step in in between building models and using them, aligning the model's outputs to your business goals. So we have a model, we've built it, we evaluate it, we like it. The next step is to retrieve predictions. There are two ways to get predictions with Amazon machine learning. The first is batch predictions. And this method is best when you have a large volume of data records and you want to get predictions for them all at once, which usually means that your application deals with data batches to start with. You can get these predictions through the console. There is a create new batch prediction button that launches a wizard. It's very similar to the wizards we have seen already. I'm not going to walk you through it. You can also get predictions very simply through the API. So here is a code snippet where we start off by creating a batch prediction object. We pass in the ID of the request. We pass in the ID of the data source that points to the data for which we want to create predictions. We pass in the ID of the model that's used to create predictions. And finally, we pass in a location where predictions are output. And what happens once you submit this request is Amazon machine learning asynchronously goes off and works. It runs through all the data records you've provided and computes predictions for all of them. And you can monitor the status of this job as it happens. At the end of the day, predictions are output into a location in S3, and you get something that looks like this. You get a CSV file which has two columns. The second column, I'll start with the second column, is the actual prediction score that was computed. And the first column is the best answer, which is obtained by comparing that score against the score threshold that we established earlier to determine the right balance of false positives to false negatives in this case. So that's batch predictions. The second interface is real-time predictions. Real-time predictions are intended when you want to get predictions and use them immediately. It is a synchronous, low latency, high throughput interface that you can use through the service API or through server SDKs or mobile SDKs. And it's the perfect fit when you have an application that deals with individual data records and needs these predictions right away. If you have a mobile application and you have a user interacting with it and you're deciding which offer to show to that user, you need that information right now. And this prediction is based on what the user is doing right now. And real-time prediction is a great choice for this. The API to get real-time predictions is very simple. We call the predict method, pass in model ID, the ID of the prediction endpoint, which can be obtained from the model itself. And finally, we pass in a data record as a list of key value pairs. And immediately, and I want to say something about latency here, vast majority of predictions will come in 100 milliseconds or less. Immediately, this prediction arrives back, and here we have a regression model, so we're predicting a value directly. So as soon as you've issued this call, you have this prediction back. We've predicted that the value is 13.284348, and we've returned some additional details about the algorithm and predictive model type. All right, last thing I want to talk about in the last couple of minutes is a couple of architecture patterns. How might you use this technology to build applications? A very common pattern among our customers is to start out with raw data in S3. This data is processed with technology like EMR, Pig, or Hive, whatever it is, and aggregated data is again output in S3. As soon as you have this data ready to be used to be fed to the prediction API, you can issue a single API call that will go and obtain predictions in batches for all the data records in S3, and the results are output back into S3 as a result file. We just looked at the result file a couple of minutes ago, and finally your application can now load this result file and use it. A second pattern is to use Amazon Redshift, which is a very similar flow, except that Redshift nicely abstracts several discrete steps away. We start out with data that's already structured data in Amazon Redshift, and we can directly create a data source on that data and use this data source for batch predictions. So Amazon machine learning can connect to Redshift directly, retrieves the data, and then use this data to create predictions. And then predictions are output into S3. Then these predictions can be fed back into your application, or you can load them back up into Amazon Redshift. The choice is yours. The third pattern is using your application to call real-time predictions. And this pattern is almost embarrassingly simple because there is just one API call. Your application starts out with a data record. It calls the real-time predict API, predictions back right away. Your application can use it. And finally, I want to show an interesting example of just to give you an idea of what's possible by what you can do by chaining Amazon machine learning with other Amazon services. So imagine we have an application, it's a pre-existing application. It does not yet have machine learning technology in it. And what this application does is collect data and places them as rows in DynamoDB. What we can do is we can use AWS Lambda to create a trigger for a new row being added to Dynamo. We can have this Lambda function call the real-time prediction API to obtain a prediction for this data row. And then we can use Lambda to write this prediction right back into the same rows that was just added. So what we have just done is take an application that collects data, and we added prediction generation as a part of this application without changing the application at all. Now we have rows in DynamoDB that have both the input data and the prediction, and a different application can now be written to read these rows from Dynamo, or the same application that generates the data can be modified post-fact to generate the predictions. So I will stop here. Thank you very much for your time.